Oftentimes, you will need to be able to convert between a name of a molecule and its structure. So I'm going to walk you through the steps with some simple alkanes. Step 1 is identify the parent chain, and to do this you have to look for the longest chain. In this example, you might think that if we go left to right, the longest chain is 4 carbon units. But that is just assuming if you're going left or right. In fact, you have to follow the longest chain, even if it snakes. So instead of this carbon being number 4, 4 would be down here, followed by 5. So in this case, the longest chain is 5 carbon units. If we look at our prefix table, that is pent. So the base name for this compound will be pentane, because this is an alkane. After you've assigned the longest chain, you need to label the substituents. Anything not on the chain, on the parent chain itself, is considered a substituent. So this group right here is a substituent. This has 1 carbon unit on the substituent, so this is a meth prefix. When you name a substituent, you use the prefix "il" or the suffix "il. So this is a methyl group. Next up, we need to number the parent chain. We know that there are 5 carbon units, but we need to be able to give this substituent the lowest number. So in this case, we can say that this is 1, 2, 3, 4, 5. Or you can number the other way, which would be 1, 2, 3, 4, 5. Now in this example, it doesn't really matter which direction you number from, because the methyl group will show up at the 3 position either way. But in other cases, you want to make sure that the first substituent that you get to has the lowest number. So in this case, when we're talking about our molecule, it's a methyl group. We're going to say it is a 3-methyl group, because the methyl group comes off of the 3rd carbon. Finally, we're going to put the name together alphabetically. We put any of the substituents, the 3-methyl group, first. So this is 3-methyl. And because the parent chain is pentane, we're going to put that last. This is 3-methyl pentane. So let's go to a more difficult example. Okay, again, we need to identify the parent chain, which is the longest chain. So I normally start one of the ends. It looks like we could probably start here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we can either go up or we can go down. It doesn't matter because there are 2 carbons either way, so let's just go down. 10, 11. In this case, it actually goes past our list of prefixes. This is undec. So our base chain in this molecule is undecane. Okay? So the next step, we're going to list the substituents. Again, let's number our chain. And circle anything that is not on the parent chain. So there's a substituent here, there's a substituent here, and there's a substituent here. So let's figure out what these are. Coming off of this carbon here, this is a methyl group. It's only 1 carbon long. Same thing here, only 1 carbon unit. This substituent here is an ethyl group because it has 2 carbons in it. Next, we're going to number the parent chain so that we get the first substituent at the lowest number. Basically, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. In this case, the first substituent shows up at 2. If we numbered the other way, starting here, it would be 1, 2, 3. The first substituent shows up at 3. So we're not going to number it that way. We have to number it so that the first substituent gets the lowest number. So let's go ahead and assign numbers to our substituents. We have a 2-methyl group. We have a 4-methyl group. And we have a 9-ethyl group. Okay, and the last step is to put these all together alphabetically. So remember, this was 11, it was undecane, that's our base. We had 2-methyl, we had 4-methyl, and we had 9-ethyl. It doesn't matter which number we're beginning with at this point. Now we're looking at the alphabetical order of the substituents. So ethyl will go first. So if we're naming this compound, this is 9-ethyl with a hyphen in between. Now we're going to put another hyphen. We have methyl groups showing up at 2 and 4. So we're going to put 2, 4 with a comma in between. Now they're methyl groups, but there are 2 of them. So it's important to say how many there are in the name. So we're saying dimethyl. If there were 3 methyl groups, we would say trimethyl. If there were 4 methyl groups, it would be tetramethyl. But in this case, this is 9-ethyl alphabetically, 2,4-dimethyl. The prefix doesn't count in this case for alphabetical order. Decane. So let's take a look at some examples where the substituents are actually more complicated than a simple ethyl or methyl group. So if we imagine that this molecule is part of a larger chain and we wanted to identify that substituent, what would we call this? We can't call this ethyl or methyl because there's extra carbon units in here. In the case where the substituent splits into this Y shape, we can use the prefix iso and then count how many carbons there are. There are 1, 2, 3 carbons here. So this is isopropyl. So we could call that isopropyl as our substituent. There's another way to do this where we label it a little bit more systematically. The site, the first carbon that connects to the parent chain, we can number as 1. And then we can follow the longest chain, 2. So this is an ethyl group with a substituent, a methyl substituent, at the 1 carbon. So we would call this 1-methyl ethyl. And what we would do is we would put this in parentheses when we use it as a substituent. So we can either call this isopropyl or 1-methyl ethyl. In the case where the substituent, again if this is part of a longer chain, branches immediately to 3 carbons, 1, 2, 3, we would use the prefix tert because this carbon here has 3 substituents. Tert, now let's count the carbons. There are 1, 2, 3, 4 carbons overall. This is a tert-butyl group. When we're listing these alphabetically, iso counts. It's been accepted that isopropyl would go before propyl, for example. But tert does not count when we're using it alphabetically. So if we had an isopropyl group and a tert-butyl group, and we were putting them in the name of a molecule, we would go tert-butyl and then isobutyl. The tert doesn't count. So we can call this tert-butyl, this is more of a common name, or we can do the same strategy that we did with the isopropyl group, where we count the longest chain. Let's cross these off. 1, 2. So again, this is an ethyl group. And coming off of the 1 carbon, we have 2 methyl groups. So this would be 1,1-dimethyl ethyl. And that's going to be our substituent. Next example, right here, if we see that the compound branches right here and continues going this way, this central carbon now has 2 substituents. We would call this sec because it's secondary. This is a sec, 1, 2, 3, 4 carbons. This is a sec-butyl group. That's our common name. If we wanted to name this systematically, we would find the longest chain. This is 1, 2, 3. So the main chain here is propyl. And coming off the 1 carbon, there's a methyl group. So this is a 1-methyl propyl substituent. Finally, if we have a compound that branches into this shape down at the bottom, it's not a tert group. Tert only means if the branching occurs here. If the branching occurs at the end of the chain, we call it a neo prefix. In this case, we just count the number of carbons. There are 1, 2, 3, 4, 5, 6. This is a neohexyl group. And again, neo doesn't count for alphabetizing, and neither does sec. If we wanted to name this systematically, we number the carbons. 1, 2, 3, 4. This is a butyl. And there are 2 methyl groups coming off of the 3. So this is 3,3-dimethyl butyl. Finally, if we have a cyclic compound, we're going to add the cyclo prefix. So the longest chain in this case is actually 6 carbons, but it's in a circle or a ring. So we will call this cyclohexane. That's our base compound, our root name. The substituent here you may recognize as an isopropyl group. So this is 1 isopropyl. We're giving it the lowest number. Cyclohexane. In this example, there are 3 carbon units in the ring, so the base here is cyclopropane. There's a methyl group coming off of here, so this is 1-methyl cyclopropane. We can also consider cyclic structures as the substituent itself. In this case, 1, 2, 3, 4, the longest chain is actually 4 carbon units and not 3. So our root here is 4, which would be butane. The substituent is a cyclopropyl substituent. So this is 1 cyclopropyl butane.